Today, we're diving into how electronic circuits can sense the world around them. Sensors let circuits detect real-world changes and respond automatically, just like your eyes adjust to brightness or your skin responds to heat. Electronic sensors like light-dependent resistors, or LDRs for short, and thermistors help circuits do the same. You've probably seen garden lights that turn on when it gets dark. Those use an LDR to detect light. Maybe you've noticed your laptop fan turn on as it heats up. That's a thermistor at work. A sensor is a device that detects changes in the environment, like light, temperature, or motion, and converts them into electrical signals or a voltage that we can measure and use. There are tons of different sensors available. Today, we'll cover how to measure light and temperature. So first, we'll cover what an LDR is and how it responds to light, what a thermistor is and how it responds to heat, how to use both in real circuits, and how to measure sensor behavior with a multimeter. Let's get started. First up, the LDR, or light-dependent resistor. An LDR is a resistor whose resistance changes based on light intensity. In bright light, the resistance is low, and in darkness, the resistance is high. In darkness, the resistance goes up. So more light means more current can flow, and less light means less current. Inside the LDR is a special material called cadmium sulfide. When light hits it, it excites the electrons, lowering the resistance, and when it's dark, the electrons settle down and resistance increases. You'll often see an LDR in a circuit diagram as a resistor with two arrows pointing toward it. Those arrows represent incoming light. Now, let's talk about thermistors. A thermistor is another variable resistor, but it responds to temperature instead of light. There are two kinds. You have an NTC thermistor, or a negative temperature coefficient thermistor, where the resistance goes down as temperature rises. You also have a PTC thermistor, or a positive temperature coefficient one, where resistance goes up as temperature rises. Most of the time, you'll see NTC thermistors. As it gets hotter, the resistance drops. And this makes it perfect for temperature sensors or fans. In a circuit diagram, a thermistor is shown as a resistor with a diagonal line and a little T to indicate temperature. Sometimes it'll be labeled NTC or PTC to help understand which one it is. Let's compare these two. LDRs sense light, thermistors sense heat. Both change resistance, and both are non-polarized, meaning you can connect them in either direction and both of them will still work. Let's explore where we see them in everyday life. LDRs are in automatic lights and solar panels, and thermistors are in laptop cooling fans and fire alarms. So why are these sensors so important? Well, it's because they help your circuits make decisions based on the real world. When it gets dark, an LDR can turn on a light. When it gets hot, a thermistor can turn on a fan. In our next lesson, we'll combine these sensors with transistors to build automated circuits like light-activated LEDs and temperature-triggered buzzers. Try it yourself and tag us with your builds on social media at Horizon Robotics Lab. See you in the next one. If you like what you've seen so far, you should visit our website and check out our electronics and coding kit. It comes with all the videos, all the lessons, all the code, all the labs, and all the project files. So yeah, link in the description and happy learning.